Cambridge IGCSE, February-March 2020, Paper 22. Solutions for question 31 to 35. Question 31. A student makes 4 resistors using different pieces of wire. The wires have different diameters and lengths. All the pieces of wire are made of the same material. Which piece of wire will make the resistor with the largest resistance? So in this question, basically you need to find which resistor will have the largest resistance. So in order to find the answer, let's look at the equation of resistor. That is, resistor is directly proportional to the length. If the length of the wire is more, resistance will be more, and inversely proportional to the area of the cross section of the wire. And in this question, it asks you to find which resistor will have the largest resistance. So, largest resistance means we can find if the resistance is larger, what will happen to the length and area of cross section. Let's look at the relation again. Here, you need to get a larger resistor. In order to get a larger resistor, the length also should be larger, but area of cross section should be smaller, because area of cross section is a denominator. When the denominator is smaller, only the radius will become greater. So we can write, in order to get a higher resistor, the length should be greater and area of cross section of the wire should be smaller. If the area of the cross section of wire is smaller, means what about diameter? Let's look. If you have a wire and its diameter is smaller, means its area of cross section will also be smaller. That means area of cross section and diameter are directly proportional. So now let's back to the relation of resistance, where we already understood that to have a higher resistor, we need a larger length and smaller area of cross section. If the area of cross section is smaller, then the diameter of the wire also will be smaller. So you can write, from area of cross section is smaller means it will lead a smaller diameter. Here you are provided with the diameter of the wire and length of the wire. And in order to get a larger radius, you should choose the wire which is having a greater length and a smaller diameter. So let's check which option is having, or which wire is having a larger length and a smaller diameter. First we can check in which options the wire is having the largest length. So when you considering the length, there are two things. One is 10 centimeter and another one is 17. So comparing to the length, 10 centimeters wires are small in length, so that they will have least resistance. But here we have to find the resistors with largest resistance. So option A and C will be wrong because they are having a lesser length. Now we have option B and D. On both the length are equal. Now let's look at the diameter. In order to get a greater resistance, the diameter should be smaller. Now let's find in which option the resistance is smaller. As you can see, 0.8 is smaller than 2, so that option D is also wrong. So the resistor wire which is having a largest length among these, that is 17 centimeter, and smallest diameter, that is 0.8, will have the largest resistance. Hence the correct answer is option B. Question 32. A student is to determine the resistance of resistor R. She uses a circuit including a voltmeter and an ammeter. Which circuit should be used? It is a very direct question, as ammeter, we need to measure the current flowing in the path. You have to always connect in series or in the path. Ammeter should be always in series. Likewise, voltmeter is using to measure the potential difference between 2 points. So that the voltmeter you should always connect parallel or across to these 2 points. So that the voltmeter should always connect in parallel with the circuit, whereas ammeter should connect in series with the circuit. Hence the correct answer is option D. Question 33. The diagram shows a battery connected to two resistors. Three ammeters M1, M2, M3 are connected in the circuit. Ammeter M1 reads 1 ampere current. What are the readings of M2 and M3? As you can see, there is a cell which is connected to two resistors and there are three ammeters M1, M2 and M3. So ammeters are used to measure the current in the circuit. And the reading of ammeter M1 is given, that is 1 ampere current. Now you need to find what will be the reading of ammeter M2 and ammeter M3. Here, by looking at the figure itself, you can easily identify, because ammeter measures the current which is passing through the path. Now if you look at the path, the current will start to flow from the positive terminal and it will pass through the ammeter M1. Then it will pass through the resistor and the same current will be passing through the ammeter M2 and it will pass through the resistor, and again the same amount of current will pass through the ammeter M3. There is only one path, so whatever the current coming, it will be flowing away. So here the current value is given 1 ampere. So the current leaving from this M1 will be also 1 ampere current. The same 1 ampere current will reach here and it will pass through the second ammeter, and again the same 1 ampere current will reach in the same path and it will pass through the ammeter M3. So everywhere the reading will be 1 ampere, because all the ammeters we have connected in the same path. Hence the correct answer is option D, where on both M2 and M3 the current value will be 1 ampere, which is same value as the reading in M1 ammeter. Question 34. A cell is connected to a parallel combination of 2 ohm resistor and 4 ohm resistor. The current in the 4 ohm resistor is 1 ampere. What is the current in the cell? So you need to find in this question what will be the current in the cell. This current will be same and you need to find what will be this value. And here they have given the values of two resistors which they have connected in parallel and value of current which is passing through the resistor 4 ohm resistor, that is 1 ampere. And you need to find what will be the total current in the circuit, because the total current will be the current which is passing through the cell. As we have this resistance 4 ohm resistance and the current passing through that resistance, we can find what will be the voltage across or what will be the potential difference across 4 ohm resistor. Because for the 4 ohm resistor we have the resistance, that is 4 ohm, and the current passing through this resistor which we have, let it be I1, which we have 1 ampere. So as we have R, let it be R1 and I1, you can find the voltage across the resistor 4 ohm, that will be V is equal to IR. So here the I is 1 ampere and R is 4 ohm. You will get the current, the voltage of 4 volt. Here you just need to use the equation, voltage is IR, V is equal to IR. So you can find what is the voltage across 4 ohm resistor. Now you can understand that the voltage across 4 ohm resistor is 4 volt. Now look at the circuit. In this circuit, both the resistors are connected in series. That means if the voltage across 4 ohm resistor is 4 volt, then the voltage across 2 ohm resistor will also be same. That also will be 4 volt. Now we can concentrate at 2 ohm resistor. For this 2 ohm resistor, you have the resistance value. Let it be R2, that is 2 ohm. And you have the voltage. We can take the voltage. V2 is 4 volt. We can find the current. What will be the current? Let it be I2. I2 will be, again you can use V is equal to IR equation. So that I2 will be equal to V2 over R2, where V2 is 4 volt and R2 is 2. So you will get 2 ampere. Now we have calculated I2, that is the current passing through the resistor 2 ohm, and you have already in the question it's given the current passing through the 4 ohm resistor that we are considering as I1. That means we have 1 ampere current which is passing through 4 ohm resistor. We are considering it as I1. Likewise, we have calculated the current passing through 2 ohm resistor I2, that is 2 ampere current. Now, the question is, what will be the total current passing through the cell? As these both the currents will be joining, the current passing through the cell will be the sum of I1 plus I2. And I1 is already given 1 ampere plus I2 we have calculated 2 ampere. So the total current will be 3 ampere. Hence the correct answer is option D. Question 35. The two inputs of a NAND gate are joined together. Which truth table represents the action of this gate? So here we have a NAND gate where you are connecting a single input. That means if you are connecting a input 0, here also it will be 0, here also it will be 0. So what will be the output? Let's check the truth table of a NAND gate. If the inputs both are 0, 0, then the output of the NAND gate will be 1. Likewise, if both the inputs are 1, 1, the output will be 0. Now look at the NAND gate where if you connect a 0 input, both the input will be 0 so that the output will be 1. So we can write when we give a 0 input, output will be 1. Likewise, if you connect a 1 input, then both the input will be 1 because both are having same connection. Then the output will be 0. So for an input 1, the output will be 0. Now let's check which option is showing this correct relation. That is when the input is 0, output is 1. When the input is 1, output is 0. So the option A is wrong. Option A is correct. Option B is correct. Where when input is 0, output is 1. When input is 1, output is 0. So the correct answer is option B.